All right, hello everyone. Hello again, everyone. It is Unit 9.3. These set of notes are going to be about parabolas, the conic section. Right at the top here, I'm just going to issue this caution warning once, right? Don't assume this is easier than it is. These are related to our quadratic parabolas, but they're not the same. There is some vocabulary, some terms, and some quantities that we haven't seen before that we will use in parabolas. So what is the conic section known as a parabola? A parabola is the set of all points in a plane that are equidistant from a fixed line that is known as the directrix, and a fixed point known as the focus that is not on the line. So in other words, we are trying to find all the points that are the same distance away from a point known as the focus and a horizontal or vertical line. So all those points that are the same distance away from the blue highlighted point and the blue highlighted dotted line are represented by our parabola, which you can see here. So some key vocabulary to fill in, very similar to what we've done earlier in the unit. The vertex is that point at the top or bottom or right or left of a quadratic that is familiar to us. Right there's a vertex, there's another one, a vertex. All four of them are in green. Axis of symmetry goes straight through the vertex. We'll do that one in yellow. There's an axis of symmetry straight through here, straight through here. Here's another straight through axis of symmetry, and another. The directrix is a different line that is the same distance away from our parabola as the focus of our parabola is. So the directrix is over on the left there. There's another directrix here. Our directrix becomes vertical on our last two. And the one thing we haven't really seen is a focus, but that is the point labeled, I can't spell today, focus. There's one there, and there's one there. We can see that we have more focus points here and here. So the equations are right about 3/4 of the way down your screen. X squared equals 4py. Right, notice that the squared term is by itself, and then there's a multiplier, a coefficient on the other side. Right, our next one, x squared is by itself, negative 4py on the other side. In our last two, y squared is by itself, and now 4p shows up attached to x, and then the same thing happens with our last one as well. So x squared equals 4py, y squared equals 4px, and all of its iterations. So let's fill in some vocabulary and fill in the bottom of our page here. I'm going to read through these. Please feel free to pause as is necessary. Number one, the vertex is the point of intersection between the parabola and its axis of symmetry. The value p, which we noticed in our formulas up above, gives the distance from the vertex to the focus and from the vertex to the directrix. In other words, the vertex is halfway between the directrix and the focus. Number three, the focus is always on the axis of symmetry with the vertex, similar to what we saw with ellipses and hyperbolas. The axis of symmetry passes through the focus and is perpendicular to the directrix. Number five, the vertex form can be rearranged slightly to be written in what we would say is transformation form of a quadratic. Y minus k equals a times x minus h quantity squared. In that case, our a value, that a value that we would have seen back in Algebra 2 and earlier in pre-calc, is now p over 4. So that a value, which told us about vertical stretch and vertical reflection of our parabolas, is now a component, right? We're using this p value to represent something a little bit different. And finally, number 6, the latus rectum is the line segment that passes through the focus, parallel to the directrix, and has its endpoints on the parabola. The length of the latus rectum is 4p. And remember, p represents the distance from the focus to the vertex or the vertex to the directrix. Just like our last few lessons, we are now going to graph some of these examples. I'm going to walk through the first one all the way, and then I will ask you guys to try 2, 3, and 4 on your own. I will walk through those ones a little bit more quickly. All right, so let's look at example 1. What we like about this formula is that we have our y squared by itself, and then we have this 12x on the other side. That 12 we can think of as 4p, right? In all of our forms, the coefficient attached to the non-squared variable is thought to be 4p. So if we divide both sides by 4, our p-value will be 3. So what that means is we can use all of this information. We can see that y squared, so we have y squared means it opens left or right. We have a positive p, which means it opens in the positive direction. So our graph will open to the right. I'm going to sketch this in my x and y axis here. And for this problem, we are centered at the origin. So there's our center. And, I'm going to go by 2 on this graph just for reference sake. So what I know is that this graph opens 3 units to the right. It opens to the right. The p-value tells us how far to the right is the focus. So if I travel 1, 2, you know what? I said I was going by 2s. So right there is the focus. And then at the level of the focus, the width of the parabola is 4p. All right, let me say that again. The width of the parabola at the level of the focus is 4p. So I know that it's going to be 12 units wide at that point, right? That 12 equals 4p. So I'm going to go 2, 4, 6 units up and 2, 4, 6 units down. I also have a p-value of 3, which tells me my directrix is 3 units kind of behind my parabola. So I can say that my parabola will have shape like this. Let me make sure I answered all of the key features. The focus was 3 units to the right of the origin. We are at the point 3, 0. The directrix is a vertical line, and it is 3 units to the left of the origin. It is x equals -3. And we've graphed it, so we are done with example 1. We use our formula to find p. P tells us how far to travel and in what direction to find the focus and the directrix. I want to give you the first step here on number 2, and then I'm going to kind of fast forward through all the other key parts. One thing we always want when we set these problems up is our x squared term to be isolated, our squared term to be isolated. So what I would do on this problem is multiply both sides by -8. So I would have x squared equals -8y. That is a graph you should try to sketch on your own. Just some advice as you work. I think going by 1s should be sufficient for this particular problem. I'd like you guys to try 2, 3, and 4 if you are able. I will walk through all of these, but I'm going to pause, work through my own, and then kind of talk through what I found. All right, team, we are back. Here is my work on example 2. If you haven't had the chance, so the first step I took was I multiplied both sides by -8. Remember, we like our squared term, in this case the x squared, to be by itself in these equations. So I multiply by -8 to create that. I then find my p-value. That -8 is now representing for p. So I'm left with a -2 for p. That means that my focus will be 2 units in the negative direction from my vertex. This is a problem where x squared is the squared term, so the parabola opens up or down, and because p is negative, that means it opens down. 2 units above the vertex is the directrix, y equals 2, and the focus is 0, -2. And that is about it. The way I am sketching these is, if I know that 4p is the width of the parabola at the level of the focus, what I am doing is I'm counting half of 4p, in other words 2p, out from that point. So 1, 2, 3, 4, and then I go 1, 2, 3, 4 in the other direction. That creates the width of my parabola at the level of the focus. So that 4p value, that -8, the negative tells us it opens down, but that 8 tells us the width of the parabola at that critical point. Looking at example 3, I have my work here. I don't think a sketch is necessary, but just to sketch out what I would have done to make sense of things. Well, if I have a focus of 5, 0, that would be 1, 2, 3, 4, 5 units over here, and a directrix of -5, 1, 2, 3, 4, well, that's over here. I know that that whole distance from -5 to +5, that represents 2p. So if 2p equals 10, p must equal 5. I jumped right there in my work, but what we need for our equation is 4p, so that's what that 20 gets plugged in right there. Our sketch would look, something like this. It would tell us that when we opened up here, this would be at -10, and that would be at +10. So the width of the parabola, right, like at this point, the width of the parabola at the level of the focus is 4p, in this case, 20. Number 4 behaves very much the same way. This is unique, not for this conic section, but for this set of notes so far. We are no longer centered at the origin. Just like with our other conic sections, that requires us to make some shifts and adjustments, but it doesn't really change the big picture. Our vertex is at the point 3, -1. Because that 4p value 8 is positive, I know this is going to open up. The focus is going to be 2 units above the vertex, and the directrix 2 units below. Let's look at the last page of our notes, and we are just about where we need to be. We have 3 more examples here. I am going to work through all of them just so you can see it happen. So we're getting close to the end here. What I notice again is that I have my squared term. I do not want this coefficient here. So I want to get rid of that -1/4. I'm going to multiply both sides of my equation by -4. And now I have a lot of information. I know that the center of this graph will be at -1, 3. I know that 4p is the same as -4, so p is going to be -1. Because y is my squared term, that means I will open left. And that's about all the information I need to pull. I should find my focus and directrix. Now that's going to be a lot easier now that I know which direction everything is happening. So my focus is going to be 1 unit to the left of the center. So my center is at -1, 3, so -2, 3 will be the focus. And the directrix is going to be 1 unit to the right of the vertex, and that is going to be a vertical line of x equals 0. So let's sketch it. This is going to open to the left. I'm going there. So I'm going to offset my grid a little bit, tilt it over to the right a little, And then I'll move it up just a tiny bit. Actually, that doesn't make sense. I'm going to move it down just a tiny bit. And now let's sketch what we know. We know that the center is at the point -1, 3. Oh, 1 over, 1, 2, 3 up. We know that we have a directrix at x equals 0 and a focus 1 unit to the left of our vertex. We know that 4p, the absolute value of 4p is 4, so that means 2 units up and 2 units down from the focus will give the width of our parabola, and that's everything we need to graph. All right, let's look at another example. Let's look at example 6. In this one, we may notice that we don't have the form we necessarily like. So we may have to manipulate this equation. We're going to start by putting everything on the left-hand side with our squared variable, and on the right, -12x plus 23. Well, now I'm going to complete the square. I'm going to take my linear term, cut it in half and square it, and I'm going to do the same thing to the other side of my equation. And what that'll get me is a form I like a little bit better. And then I'm going to have -12x plus 24, so that's going to turn into a -2. So just by completing the square and reorganizing, we now have a form we like quite a bit more. We can tell for this graph, we should have I say center here, I meant vertex. We have a vertex at the point 2, -1. We know that 4p is the same as -12, so p is going to be -3. Because our y squared is our quadratic term, I suppose, we are going to open left and right, and with a p-value that's negative, we know that we open left. And I think that might be all we need. So 2, -1. I'm just planning out my graph here. Don't want to shortchange too much with space. All right, so we start with our vertex 2, -1. It is there. We know that our p-value is -3. So 1, 2, 3 units to the left. And then 1, 2, well, it looks like I shortchanged our directrix, but it would be over here at x equals 5, 3 units to the right of our focus. And then at the level of our, let's write our actual focus. I think I just misspoke. Our focus is this point here that I've just highlighted in red. That point is 3 units to the left of our vertex, so it is at the point -1, -1. And I think that's all we need for key features. Now we're going to go to the vertex. Right, we know that's where our graph starts. We know at the level of the focus that our graph should be 6 units, twice p, wide, so 1, 2, 3 below and 1, 2, 3 above. Now we have the shape of our graph, and that's all we need for this parabola. A little bit easier to sketch these parabolas as long as we are systematic in approaching their vertex, identifying the focus, and the directrix. One last problem here. We got a word problem. The receiver of a parabolic television dish antenna is 3.5 feet from the vertex and is located at the focus. So what that means is that the distance from the vertex to the focus, well, that's p. We can see that this parabola opens upwards, which means x squared is going to be on our left side of our equation. And on these problems, what we've been doing is we've centered them at the origin whenever possible. So we know x squared is going to equal 4py. Well, 2p is 7. 4p is 14. So x squared equals 14y is our equation. We are done.